Throughout the day today here at Emerging Technologies track, we've been talking about disruptions across various industries in technology. And when we talk about emerging technologies, clearly mobile is always sort of in the forefront, right? Mobile in itself has been around now, for what it seems like ages already. But the kind of innovations and the disruptions that are happening in mobile is kind of mind-blowing in that it's opening up a lot more channel for a lot of other upstream and downstream businesses to sort of go mobile and be very productive at it and sort of wow the users, right? So in this session today, what we are covering is a series of talks called our Lightning Talks. And here's kind of what's packed for the hour. We will start with cellular technologies, right? So 2G was so yesterday, and 3G is already very yesterday. And so we already have 4G, bandwidths, and then 4G LTE and things like that. And we are getting very used to, advancements in cellular technologies, right? So today, the first opening session that we have is by Sujata Ganti from Intel Communications, Mobile Communications. So she's going to actually give us a demo and talk a little bit about 4G LTE carrier aggregation, right? So I'll let her speak more on that topic. So we will cover that first. And then, 4G is, becoming yesterday's technology already. So we're looking at the emergence of 5G. And Sandhya Prema from Cisco will sort of take us through a walk. She'll walk us through, what is it that we can expect in terms of the 5G technology, and what is the belief system right now, and what are the enablers, and how does the future look, etc. We'll kind of round out the cellular technology topics, and we will then get into a very interesting topic of proximity technologies, right? So if you've attended one or more sessions here, I think, somewhere we have really covered aspects of proximity technologies. You're closer to, MFCs or beacons, and we use Bluetooth for a lot of things. So how do you use proximity technologies to build, different apps that, solve different use cases? And what are the technologies that can typically be used, and, how they rank against each other? So that's something Pragati Rai will cover. This is the lineup that we have today. And so without taking much time, I will hand it out to Sujata. Thank you. Okay. So as you can see here, we have a large equipment, unlike any other talk that we've done today. What we're actually trying to do is actually show the impact of simulating carrier aggregation. And we'll get into the details as the equipment is back online. The idea is, carrier aggregation is sort of available in the Western world. It kind of increases bandwidth inherently for the users. It's still not something that's available in India, right? There are several factors to why it's not, and we'll also get into the details of that. So now I think, if you could please bear with us for a minute or two, so we'll get the equipment online, and Sujata will take over. Thank you.
Hello. A very good afternoon to one and all. I'm Sujata Ganti, and I'm working in Intel Mobile Communications. So I'm primarily working in 4G technology. So I'm a handset side 4G protocol stack developer. So today my topic is carrier aggregation. So all of us have heard about 4G because every day in the TV ads we see Airtel 4G and Samsung 4G ads. And in India also slowly 4G network is getting deployed. Now my topic is on LTE carrier aggregation. Carrier aggregation is an LTE advanced feature. This LTE advanced network is being, it's already deployed in European and US countries. In India it has not yet come, so that is why we do not have the CA feature here. Even though my handset, which is from US, supports carrier aggregation, I cannot use it here because the network here does not have the CA support. So, yeah, okay, coming to the slide deck. Yeah, this chart shows the various cellular technologies and their downlink speeds. We all have heard of WCDMA, which is 3G, and HSPA and HSPA Plus are 3.5G generation technologies. And LTE, which we are hearing now, supports a maximum downlink speed of 100 Mbps. So to further increase the speeds, which comes under LTE Advanced, we have, which can support up to 1 Gbps. To support up to 1 Gbps, the features that are required are, one among them is carrier aggregation. So carrier aggregation, as the name suggests, it is aggregating of carriers. That means aggregating of bands. It is very straightforward that if we increase the bandwidth of the pipe, the capacity will increase, the throughput or the data speed at which we receive data at our mobile end will increase. So carrier aggregation is simply aggregation of carriers or aggregation of LTE bands. One of the driving factor for the networks to go for carrier aggregation is normally network operators do not get, it's not easy to get the spectrum or large spectrum, like the maximum bandwidth in LTE is 20 megahertz. So most of the carriers, most of the operators either cannot afford for such a large spectrum, or they may not get a continuous 20 megahertz spectrum. So they may get chunks of spectrum across various LTE bands. For example, say 10 megahertz in one band and 10 megahertz in another band. There are various LTE bands, like various range of frequencies. So in order to effectively use these small chunks of various bands, they have to add them up, that is aggregate them across various bands, and this is nothing but carrier aggregation. So as the slide shows here, this is a conventional LTE network. For example, the network that we have in Bangalore, LTE network. The maximum that it can support is only 150 Mbps speed. So, that also if a 20 megahertz, this is the largest band available in LTE. There are various scalable bandwidths like 1.4 megahertz, 3 megahertz, 5 megahertz, so on till 20 megahertz. So if a user can get all the 20 megahertz, then he can achieve a speed of 150 Mbps. But in practice, practically, all the entire bandwidth cannot be allocated to a single user. Obviously, there will be many users, and only small parts of the bandwidth can be allocated to him. If the user wants more data, then obviously they have to add up more carriers. So this is an LTE advanced network which supports carrier aggregation. So in this, as we see, the different carriers or the bands are added up so that it becomes a bigger bandwidth. And obviously, at the end user, that is at our mobile, we can receive around 300 Mbps. This is in case of two carrier aggregation. Here, each carrier can give maximum of 150 Mbps. So two carriers can give 300 Mbps. Of course, this is a theoretical value. So, and Intel has released its modem. Intel mainly provides modem at the handset side. So Intel has released its modem with 2CA. 2CA means two carrier aggregation of two carriers. Today my demo is regarding the 2CA. So the big box that you see here, this is the network simulator. Network means the towers that we see, cell towers outside. Those are called the eNodeB B tower. Okay, here I have set up two cells. Two cells means, okay, one is the, as I said, two carrier aggregation. We have a primary cell and a secondary cell. In this box, I have configured both the primary and secondary cell so that to show a throughput of 300 Mbps. Unfortunately, at the last moment, due to some glitches, I could not show the, back to the PPT, please. Yeah. Okay, the two cells, this is the cell tower that we have. This is one cell maybe operating on one band, and this is the green color, another cell. So if carrier aggregation is enabled, a user who is present in this region can achieve the data from both the cells. So the data rate at which he can achieve will increase. That is what I want to simulate here. As shown earlier in this box, I have configured both the cells, I mean both the primary and the secondary cell. And I have a tool, this is for the throughput testing to see how much data we are receiving from the network. Unfortunately, this tool stopped working, but here we can see the bandwidth that can be achieved when both the cells are enabled or if only single cell is enabled. Maybe I will see if I can fix this, and maybe later I can show you the throughput that we can achieve by enabling both the cells or by enabling only a single cell. Yeah, thanks.
Hello, ladies. I think I just wrote this. So how many of you here actually have 4G enabled on their handsets? Okay, quite a handful. So what I feel is we just barely got our heads around the concept of 4G, and the industry is talking a lot about 5G. There is a lot of research happening on this front, and today we will see about, can you put the slides? Okay, before they set it up, so do you guys have any expectations on 5G? What do you think will come in 5G? Cheaper? Good. Faster? Good. What else? Availability? Yes? I couldn't hear. Reliability? Exactly. So more or less, you guys have actually set the goals to the industry for what the industry has to deliver for 5G. We'll go through these slides. We'll see about what makes the service provider actually go for 5G. Because if we see 20 to 25% of the world is still not connected at all. And then most of the connected people are still with 2G and 3G. 4G is still getting rolled out. Now, what makes the service provider go towards 5G? We'll see that drivers, and then we'll look at what are the use cases that 5G supports. What is it that we can expect? What magic can it do? We'll see that. And then what on the technology front will enable the service providers to achieve the goals that is set by the market and the use cases. And then we'll finally conclude on what it is all about. I'll quickly touch upon what it is, how the evolution has happened. The G we have been standing so far stands for generation. I hope you all know about it. We started more than 3.5 decades back with 1G, which is analog, then 2G, where the voice was still a priority, high quality voice rather, and then came 3G, where voice was a given, mobility was also given. Then people started using data, which was very slow in 2G. So in 3G, data got some priority. For a reference, I can say a HD movie can be downloaded in about 2 to 3 hours in 3G. Then came 4G, because people started using data more. There are more applications that have come in the market. Everything you can do online. All the smartphones are connected. There is tremendous data flowing in the cellular network. So the 4G has come, which will increase the bandwidth and the speed. So again, for the reference, a HD movie can be downloaded in probably 2 to 3 minutes. So that's the speed we have seen so far. Now so mobility is given, voice is also there, high-speed data is there. What more can we see in 5G, right? Now I can actually see some people saying, thank God my applications won't stall, right? I don't see that buffering picture coming on my videos anymore. If you are any other internet, mobile internet that we have today. Now, we have actually put the date as 2020 here. Now, why 2020 and what is it that is coming in 5G? So, according to all the reports or the analysis that we have seen, okay, so we can see that the mobile internet users number increases by multifold if we continue the same growth path. We can also see that more and more device connections can come. The data usage will increase by 300%, and there will be definitely more video viewing. There is more statistics here if somebody is interested. Basically, what it says is by 2020, the networks may not be able to support what we are seeing here. So many devices and the data. So that is when 5G will actually become a reality, when 4G can no longer support the applications and use cases that the market demands. So what are the applications and use cases? We'll briefly touch upon, there are several applications. We'll look at some of the few interesting applications. Yeah, another interesting tidbit probably is Japan is going to introduce 5G in 2020 Tokyo Olympics. And there is no better time and place than that when the whole world is watching Olympics, right? So we'll look at some of the applications that Japan is trying to introduce during those Olympics. As we have already seen in the previous slides, the data throughput through the network is going to increase by 300%, and majority of the consumption will come through the video. So the handsets, the smartphones, the tablets will form the major base, the user base, which consumes so much of data. Apart from that, we'll also see the video, the smart TVs. Today, we are getting the channels through the satellite. Probably all the smart TVs will be connected to the internet, and we get everything through internet. E-health, it will actually become a reality after some days when the HD video can be broadcast to the doctor who is sitting remotely, who can help either in diagnosis or even surgeries. Augmented reality. So this is where I said Japan is going to, so what Japan is trying to do during the 2020 Olympics is they are planning to give goggles which are similar to Google goggles. So when you wear them, in fact, during the Olympics, right, you will see people from different parts of the world will go there to cheer for their countries. Now, when you wear those glasses, you will be able to read in Japanese. That's what Japan is planning. So what they say is when you wear the glass and read some hoarding or some board in Japanese, the glass should be able to detect where your eyes are seeing, should read that, send the text to the server somewhere remotely, and then convert that back into the language that you have chosen and display the text instantly onto your goggles. So this cannot take more than a millisecond for the whole thing to happen. You can't keep staring at the board to understand what it is, right? You have to move on. This requires ultra-fast, real-time network available for it, which 5G can support. And another application they are trying to give is when you are in such a place, you would want to sit with the fellow countrymen, right? Sit with your people, sit together, and cheer for your team. Now, how do you identify among millions of people there? So the glasses that you wear is supposed to show you the bubbles. When you are walking in an aisle and there are hundreds of people around, the glasses are supposed to give bubbles on top of the people that you see with a name and the country from where they're coming from. You can instantly identify your fellow countrymen, go shake your hand and say, boss, I'm here to support our country, let's sit together. So this also cannot take more time than a fraction of a second because you will pass the person before you identify, right? So all these need a good speed. So that's nothing but augmented reality. So glasses is one example. There are a lot of other applications. You can just wear them and walk on the street, and you can actually on the glasses see what each shop around has, what are the offers going on. A lot of other things can be done with that. Industrial automation. There are a lot of industrial applications or the areas where the environment, the terrain, and these things are hazardous to a man. Mining, for example. The terrain is bad, the air is polluted, but still, right now, there is no alternative than a man to go inside and do it. With this kind of automation that's available, what they're expecting is all the machines or the vehicles can be controlled by a person who is sitting 50 or 100 kilometers away. These vehicles are connected through the wireless connectivity and through the internet to that person. Now, how is this going to help? It's not just the vehicle that's being connected. The vehicle has to send a 360-degree video of the surroundings that it is in, which is a high bandwidth data. Once the data is being sent to the person who is operating, he knows which terrain this vehicle is going to, and in a fraction of a second, he should be able to take a call to carefully maneuver the vehicle, right? So these kind of applications, there are plenty. This is just one example. These kind of applications will also come. We will see that. Self-driving cars. This is an interesting concept. I am sure somebody who is having a session on IoT or connected devices may be talking more about it. But what basically this does is these self-driving cars, the response time is very quick, way quicker than human beings. So what they say is when this becomes a reality, it can help avoid accidents. It will also know, it will be able to talk to the other car coming in the same direction or opposite direction, understand how the road conditions are forward, how the traffic is. It will take a call on what best route, alternate route is available. Perhaps you want to take a metro to reach it faster. The car will take a decision that you're not safe to drive this road. It will go and drop you near the metro, so you have to take it. So that may become a reality at some point. Civilian drones. I'm sure many of us would have seen already that most of these marriages these days, you see the civilian drones taking the camera up and taking a picture of the marriage hall and those things. So there are going to be much more useful use cases for these drones than what we see today. Governments are working on legalizing them to use what spectrum that they can use and the other aspects of it. So they are mainly helpful in a couple of things. One is agriculture. You cannot monitor your thousands of hectares of land with one person. You can use the drones, which may have the near-infrared sensors, which are harmless. They can go around the field, monitor the entire field. It can be configured in such a way that when it identifies there is a problem with the crop, it can even go ahead and use a pesticide or a fertilizer accordingly. That's going to help tremendously. And also in the rescue operations where man cannot reach. We see a lot of cases where people go missing in hiking, right? So these drones will actually help identify and help those people. Sensor networks. When we talk about smart cities, we will actually see the entire power grid, all the homes, the traffic, everything will be connected to a centralized monitoring place. So that needs internet. So that's going to be a huge network. Home automation. All the devices inside the home, again, are connected to the internet. You can control a small use case. Somebody unexpectedly, or your parents or in-laws have come home and you don't have the key. How do you handle? Sitting in the office, you can send an SMS and the door opens. So these are the small examples for home automation. Voice definitely forms still the centerpiece. So what we can see with all those applications, right, are the points that you guys have just mentioned. One is high throughput. We'll definitely see. HD video can be, HD movie, Ultra HD movie can be actually downloaded in less than a second or two. So that's the speed you can expect. And then the latency. Latency is, the less the latency is, the more real time it is. Right now, in her previous slides, she has shown the latency in LTE advanced itself is around 5 milliseconds. This is going to be less than 1 millisecond. It's going to be ultra real time. It should be highly reliable. It should be highly available because we are connecting all the devices, everything on this earth, to one data center. It should have high capacity because billions of devices would be connected to the network. And it should be cost economic. The device cost as well as the cost to support all this application should be very low. So we can say these are the 3 or 4 or 5 goals that 5G has to work on. So this is what it is. So what customers expect is the 0 latency gigabit experience. What we have is a megabit experience right now. And then there should be a lot of flexibility in the network to support what is unknown today. Right now, we do not know how else we are going to use 5G. But the network should be capable of allowing to add more applications. So we have discussed about all these things, and security is something that I haven't talked, but that forms the critical requirement, because as we said, every device, everything is, including your power, everything is connected to the internet, so it should be highly secure. So what helps the network service providers or the networks to achieve these goals set by the market? There is a lot of research happening in the big companies about what changes in the technologies can actually drive this. So these are very few that I have mentioned. There are a lot more. So on the access side, we are having a research happening on using the millimeter wave. The advantage with millimeter waves is that it can support gigabits of speed, but the disadvantage at the same time is the range it supports is less than 10 meters. But how this is going to help is probably when you have the device-to-device communication, which will offload the network from some of the data. So this is going to help. MIMO, so this multi-out, this is going to help increase, reduce the losses. So obviously, it's going to increase the bandwidth. To reduce the cost, RAN can be virtualized. Named data networking, this is going to be the next. Cisco is at least predicting this to be the next 50 years of internet. So this is going to help us connect billions of devices. We may not exhaust out of IP addresses. This SDN, this is where we actually separate the control and data planes. This is going to help us in reducing the latency. It's going to be a real time. Network function virtualization. Again, this is going to help in reducing the cost, and also for the networks to give that flexibility to add on more features and more applications. So this is at a very high level what NDN, SDN, how we are separating the control and data planes, and the network function virtualization. So what elements in the network can be actually virtualized. So this is about, at a high level, what 5G is and what we can expect. So if you have any queries, I think we are running out of time. In the end of this entire session, we can discuss more. Thank you.
Will, please. Thank you very much, Sandhya. So I think we can't be any more excited, after listening to these things, how it's really going to impact our everyday lives. I, for one, cannot wait for the day where I can send an SMS and lock my door. Right? So very interesting indeed. Thank you very much. As Sandhya mentioned, we are putting off questions for the end of the session. So please hold on to them and point out the speakers, and they'll be happy to answer your questions. So next up, I want to invite Pragati Rai. She'll talk to us about proximity technologies.
Okay. Hello, everyone. My name is Pragati Rai. I'm a director and senior innovation specialist at Deutsche Bank. I've been working in the mobility field for the last 16 years. And my first experience with the proximity technology was in 2010 when I was working with PayPal. And we were trying to create a prototype of how to make contactless payments by contact using NFC. And that is when I got smitten by the proximity technologies, and they haven't lost their allure till now. So for the next 10 minutes or so, let's all enter the exciting world of proximity technologies. Oops, again. Since we only have 10 minutes, I have divided my presentation into 3 groups. In the first part, I want to talk about what proximity technologies are, right? Let's understand some of the examples of proximity technologies. The second part will focus on some of the well-known use cases of proximity technology that are in production today. And as we do that, let's analyze why, for that particular use case, we chose a particular proximity technology. Finally, I want to leave you with a slide that contains a set of parameters that you should take into account, or we should take into account, when we are contemplating which proximity technology to use in our application. And I know many of you are already working on some of these technologies or are helping develop them. So if you have any additions or anything to add, please raise your hand and let's talk about it. So, what are proximity technologies? Very simply put, and actually this is pretty exact, these are wireless technologies, and they enable exchange of data in a very short range. What is this short range? Now, this short range could be as short as a few centimeters, like 2 to 3 centimeters, or could be as wide as 100 to 125 meters. And these technologies have been in existence for a long time. One of these technologies, like RFID, has been in existence since 1970. So they have a huge legacy behind them. But on the other hand, we have Bluetooth Low Energy, whose specifications were written in 2010. So you see, we have a whole spectrum there. Again, some of the technologies like NFC work in a very close range, like 2 to 3 centimeters, whereas the others, like Wi-Fi or even Zigbee, they have a range of over 120 meters. So you see, we have a bouquet of these technologies. We have Wi-Fi, we have NFC, we have ANT, we have Nike Plus, we have plenty of those. Some of these are proprietary, like the Nike Plus that was developed with Nike and Apple together. That's a proprietary protocol. But then there are some, like NFC and Bluetooth, that are open for anybody to use. And of course, we have some in the middle, like Zigbee, which are free for non-profit use, but for commercial purposes, you have to pay a fee. Now, next in, what I'm going to do is, let's run across a few well-known examples where proximity technologies are being used, and let's think why a particular technology was used. So this is a very well-known example these days of that of a beacon. So let's just talk about it a little bit. Now, beacon is actually using the Bluetooth Low Energy technology. Let's see how it works. So this interesting looking, a bug-like of a object that we see on the right side is actually a transmitter. And what the transmitter does, every few seconds, or how you program it, every seconds, all this beacon does is says, hey there, my unique ID is XYZ. That's all it does, okay? Then there is another transmitter that is doing exactly the same thing. Hey there, my unique ID is ABC. That's all the transmitter is doing, and it is broadcasting this message every second in a radius of 100 meters, which is what the range of BLE, Bluetooth Low Energy, is. And this message is just being broadcasted. Now, if I have a Bluetooth Low Energy device or a Bluetooth Smart device, I'll just pick it up. I'll pick up this golden nugget of information, which is my UUID is ABC, okay? So I will intercept that packet of information. Now imagine, now that we know how it works, let's imagine a scenario. I'm going to a mall, right? I enter Phoenix Mall, and this device is strategically located in front of each of the stores in Phoenix Mall. So I walk past Fab India, and my Bluetooth smart phone intercepts a message. And that message is, "Hi there, my UUID is ABC." Okay, now my phone has received this golden nugget of information. Now it is left to the imagination of an app developer of how to use this information, right? And what an app developer can do? Well, if I am a Fab India app, I'll intercept this message. I'm a smart marketer, and I'll use it to convert this piece of information into mobile commerce. And I'll say, okay, come on board, buddy. Here are all the offers that we are running in Fab India. Come visit us, right? So there are different kinds of ways this information can be used. Okay, now, the important question is, why did we use BLE for this? Wouldn't NFC have served the purpose? Why not Wi-Fi? Why not simply Bluetooth? What is so special about BLE that we use this BLE for this particular use case? Okay, now let's pause and see what are the requirements of this use case. First and foremost, what is this transmitter doing? It is broadcasting messages. So we needed a technology that was capable of broadcasting, right? Second, now I am a customer. I mean, each one of us who has used Bluetooth or has a Bluetooth headset knows that we have to do that pairing kind of a thing, pairing ritual to make a connection. Now, if I'm a lazy customer just walking into the Phoenix Mall, I'm not going to go next to each transmitter and pair it up, right? I want a connection that is very seamless. So Bluetooth is one such technology that enables seamless connection. Wouldn't NFC had worked for this scenario? Now, that's another question. Well, the range of NFC is within centimeters, right? And we just want a broadcast. And within a range of 100 meters. I have to be really close to a transmitter to intercept the message if it is using NFC. Okay, another few things to keep in mind for this use case is, these transmitters are going to be placed all over my mall, right? Even inside my store as I'm browsing through the aisle. I need something that can be mass-produced at very low cost, right? And also, it is cumbersome for me to go every few weeks walking around the mall and changing batteries. So it has to be low power, low cost, able to broadcast, and within a reasonable range. So that is the kind of technology that I wanted to use, and BLE actually fits the bill really, really well. Let's move on to the next use case. Google Wallet, right? Google Wallet is using NFC. So payments, mobile or contactless payments, is one of the very good use of NFC technology. Now, how does this whole thing works? The point of sale device on my left-hand side is NFC enabled. My app has a secure element in it. Not my app, actually. My phone is NFC-enabled phone, and it has a secure element built in it. Now, a secure element, what is a secure element? A secure element is, as the name suggests, it is like a tamper-proof, it's like a tamper-proof device. Could be a chip, could be an SD card, which is very secure and can hold my information about my keys, about my financial records and stuff. Now, with a new protocol of host card emulation, we can even do it in software. So my phone is NFC enabled, and it has an app. So whenever I have completed my shopping and I'm ready to check out, all I do is I wake up my phone and I bring it in close proximity to the point of sale terminal, and just like I would have made a payment using my credit card, exactly that happens, but my wallet remains in my pocket, and I just walk out. So this is how Google Wallet works. The important question is, why NFC? Why not BLE? Couldn't BLE have served the purpose? First thing is, now let's go back to the use case and see what are the expectations of the use case. One is, I want something which is very close, right? The connection should be made in close proximity. I do not want a 100-meter range in this case. I want like within a few centimeters, right? Second thing, what kind of a protocol would I use? Would I use a protocol or network would I use? Would I use a packet switch network or a connection model? I would want a secure connection if I am exchanging financial details. NFC is one protocol that enables a connection between two devices. So I create a secure connection between the point of sale and my phone and transmit financial details. Again, my phone has a secure element, and I can store my credit card details in a tamper-proof environment. Of course, NFC devices are more expensive to produce. They do use very low power, but they are expensive to produce. Okay. So the question is, what if somebody just steals my device and flashes it? Wouldn't that make a payment? Very valid point, and therefore, when you have to go to a point-of-sale device and make a purchase, you have to wake up your phone. You have to log into your phone and enter your password. So that is one thing that is required in Google Wallet. Okay. Let's move on to a sensor network using Zigbee. Now, what is a sensor network? Let's imagine that we want to monitor the conditions of a forest. We want to be aware if there are any unexpected incidents that are happening in the forest. Like if there is a forest fire or if there is flooding in that area, I want to know about it. So this is the kind of monitoring I want to do. What would I do? The way this works is, imagine in college we all have read about the tree structure. There's a node, and then there are child nodes, and then there are leaf nodes. Imagine that kind of a structure. Imagine that the leaf nodes, which we are going to call the Zigbee client nodes, are distributed in a region. Okay? And they are talking, they are sensing the environment, they are sensing if there is a change in temperature, if there is a change in humidity, and are sending it to their parent node. A similar thing is happening in another area of the forest. Again, all the leaf nodes are distributed, and they're sending information to their parent node. Both the parent nodes are sending it to their parent node, and finally it reaches all the way to the root node. And the root node is nothing but a computer or a human who is continuously analyzing the situations and making smart decisions and understanding the data. So Zigbee is an ideal technology to use in such kind of an environment where we want to monitor and sense, situations. So this was one of the pioneering technologies that could be laid out in mesh networks and also in tree structures. Other technologies do that, but this does it beautifully. And so we can propagate a message through long distances by hopping onto nodes. And that is why this technology is beautifully used in this particular scenario. Oyster card. Anyone who has gone to London would have used an Oyster card, right? If you are traveling through the subway or through their transport, their public transport would use an Oyster card. Very easy to use. It's a card that has an RFID chip in it. Then there are readers that are placed strategically. So as you enter the subway, you tap your Oyster card, and then you take the trip. When you're coming out of the subway, you tap it again. Very simple communication happens between the reader and the card. The information is read, appropriate amount is deducted, and written back to the card. Very simple. Now the question is, why RFID for this? Right? First of all, very simple technologies. We do not need very complicated stuff here. The card is a passive card, very limited computational powers, nothing great. Reader is stationed at secure locations, and it is properly covered, so nobody can just pick it up and steal it. So RFID works beautifully in this scenario. Maybe by the end of the presentation, I'll understand which button to press to move forward. So, sports. Now, Nike Plus is a proprietary technology developed by Apple, of course, proprietary, right? And Nike to monitor the activity of athletes. The transmitter is inside the shoe, and every second it sends out a signal to my iPhone or my Nike sports band or iPod, whatever device I have. So it sends a signal. And if I'm not moving around, it sends a signal every 10 seconds. So this is a technology that's used for monitoring activity. Consumes way lot power. The battery only lasts for 1,000 hours, which is 4 months. Actually, in this case, the communication happens in clear. Nothing is encrypted here. Very easy to sniff. So this is Nike Plus. Now, which technology should I use? I have written a host of parameters over here, but when making a decision, as we talked through different use cases, these are some of the parameters that have to be kept in mind. How much time, Rupa, do we have? Okay, so first of all, based on your use case, you will either use a proprietary or an open source or an open technology, right? Second is, you have to understand what is the consumption on your power. Expensive, of course, it's going to be mass produced, or is it going to be a few niche areas or a few elite customers you are going to be working with? Network topology. Are you going to work in a mesh network? Is it going to be point-to-point connection? Is it going to be packets that will be broadcasted? Or do you want a persistent connection until the transfer is complete? What exactly do you want there? Performance. Now, performance, in what respect? Do you want a high data rate? For example, technologies like Zigbee, I think, has a data rate of 152 kbps, whereas Wi-Fi has a high data rate. What is it that you want? Then power efficiency, robustness, let's talk about something that we haven't spoken about, maybe coexistence. What does coexist? That you are already using a particular technology, let's say RFID, and then you want to start using a new technology, then maybe NFC is a better choice, because NFC is built upon RFID. Is it that you are using 3 or 4 technologies which are going to share a spectrum together? Would that result in overcrowding? Would that result in a decrease in performance? How will that work? That's another question to be asked. Another question regarding coexistence is, let's say there is an NFC transmitter and there are 10 different NFC tags. Right? Again, this is a coexistence scenario where you have multiple readers of one technology, and then you have one transmitter. So all these kind of factors have to be taken into account when you write your app using a proximity technology. Thank you.
So we'll probably have time for a couple of questions, so we'll open it up for any of the three topics. If you have questions, please feel free. Yes.
So I was impressed with the Nike Plus technology, which you said it was proprietary. And I was just trying to relate how, is that the same technology that we have in the latest that we are coming as wearables, Fitbit and all those things?
Which technology? Ant Plus?
Nike Plus. Which
Nike
is
Plus,
Nike
okay.
Plus.
Yeah.
So is that the same thing that is being used for Fitbit and all those things, or why is it different?
So, for Nike, so this is basically used for Nike shoes connecting with Apple devices. So that is where it is used for. There are, hello. There are there is another competing technology called Ant Plus that is also widely used for sports and activity, monitoring activity fitness, but that is again proprietary. So both of them are proprietary technologies. Share it? I don't know about that one. Yeah.
Hi, my question is for Sandhya. So basically, we didn't cover the 5G architecture change, which would be needed from 4G to 5G. So when we jumped from 3G to 4G, we had to change the eNote B to go to OFDMA, MIMO, then we had to change the backhaul from T1 to Ethernet fiber. So what all changes are expected from 4G to 5G?
So last couple of slides, I have actually covered a few things that can change on the access side as well as on the network side. It depends on what the service provider wants to achieve, and there is still some time till we figure out the best way to get those bandwidths and latency rates.
So those things are still not defined yet.
There is a lot of research going on, but yes, at conceptual level, we know that the MIMO, millimeter wave technology, SDN, NFV, and these things definitely will help in achieving those.
Okay. But no change in backhaul so far, which is defined.
There will be.
Okay.
Yes, so if you have seen your handsets, you have, yeah, so her question is, do we need to change the device to access 5G? Definitely yes. The device has to support those speeds and the latency, and probably the frequencies, and the access side, if there is a change, the device has to support. If you have seen the old phone that we have used in 90s, right, that's 2G phone. Later 3G came and you had to change the handset. 4G came and now you are using a different handset. A similar revolution happens there too.
Hello. Yeah, there's a question. So there was a forward that was flowing across, which was a joke sort of thing, that we'll believe that technology has reached its limit when you are not able to find your mobile, which is on silent mode, and it says, "Hi, I'm below the chair." So will this BLE will say that, okay, I have made the communication and your mobile is right there. So it's something which I had a query. Will this ever happen? So if that can help, that I have already spoken to your mobile and it says it is right there, it has detected the location or something.
Yeah, add keys to that. We keep losing the house keys everywhere and car keys. So if they can say, "Hi, I'm here,"
Exactly.
this is, yeah,
True,
it's
true.
going to help. But yes, it has nothing to do with 5G. Definitely it will evolve to that.
Okay.
So interestingly, it is not a joke, right? So there are emerging technologies in what is called as location of things, right? So from Internet of Things, we've now moved on to location of things. So one of the most underplayed technologies that we have today is the power of GPS, right? All the geospatial data that we can use to create, empowering technologies like that is, I believe, maturing. And if you want to follow what's happening in location of technologies, so they basically have sensors on the phone and the keys that we really do lose. And, you can pair it up to any other device, maybe even up to a smart TV. So they kind of talk to each other and you'll still be able to locate the devices, right? So definitely not a joke, and we can see that coming up soon.
And also Zigbee is one of the technologies that they use for this smart home automation also.
I had a question around proximity technologies. Hi.
Hi.
Shruti here. The use cases that you covered are mostly consumer-based
Yes.
and end-user-based. Is there an enterprise application for proximity technologies specifically, or is it all based on consumer-side technologies or technology solutions?
One application I can think of is we use it in our Deutsche Bank cafeteria. We have these cards. Sodexo cards is what we call that. So instead of giving out the Sodexo passes, we actually get a card. And it's much more convenient, tearing out this is 20 rupees, this is 100 rupees, and giving it to this. We have a card which we use to make payments in our cafeteria. So that is one, again, it is a consumer technology, I would say. I haven't, good question, you're spot on.
That's something that struck me about
Yeah.
all the,
Yeah.
it's a very end-user based,
Yes,
these
yes.
technologies.
Yeah,
Thank you.
thanks.
Thanks, everyone, again. Thank you very much. So if you have questions on the LTE carrier aggregation that we couldn't really finish, you can please stick around and talk to Sujata. She'll be happy to show you a demo. Thanks.